Okay, we continue. So now we have set the instances into 3. So we create these 3 more conrod. 1, 2, 3. If you click apply, it will add more, 6 total of them. So no need to click apply. Right, so you refer to these documents. To define the direction of creation, check x-axis. Okay, so this is y and this is z. There's another way to define it. You can select a line or axis or edge in the geometry. In this case, the coordinate of this element appears in the result field. Click the reverse button to reverse direction. The application previews the location of the new component. So we can select reverse or selected element. That, so it will follow this. And then okay, then we look at our document. Make sure the option defined as default is on. If it is so, the partition after this one are saved and be used by the fast multi-instantiation command. Okay, so we don't have any on here, but this is defined as default. It means later if you use the multi-instantiation, it will keep this number and this spacing. Okay. Click OK to create the components. 3 additional components are created in the X direction. So we want it to be in the X direction and over there. Let's see Y. In our case, it is Y. Okay, let's put it here. So now it has created this conrod 2, 3, and 4. So now we will do the fast multi-instantiation. This task shows you how to repeat components using the parameters previously set in the define multi-instantiation command. So we have defined previously, so now we can use straight away. Select the component we wish to instantiate, that is pin. So now we will instantiate the pin. Click the fast multi-instantiation command or icon. The result is immediate. 3 components are created according to the parameter defined in the multi-instantiation dialog box. So now we'll select the pin. So this is the pin. So we'll select not defined, but we select fast multi-instantiation. So as we can see here, it has created 3 more pins. Now our work is to separate all parts. Let's use this fast manipulations and remove it to X. Tiga. 1, 2, 3. While this is, we can move it to Y. 2, 3. Click OK to save changes. We'll go to the next page. Now redo assembly step 3 to 10 to complete the assembly. At the end, press update all button again. This means that we need to do constraints, that is coincidence, and also the offset constraints. Let's do this one by one. First of all, let's do consider constraint between this to this one. If we look, we have 2 different shafts over here. Select the smaller one. You can click update anytime. Okay, next we will create shaft. Offset constraint from this to this. It is 2 mm. Okay, update. Okay, this now moving. So let's continue to other conrod. Click this and this. Okay, and also create offset constraint between this surface and this surface with same value, offset to mm. Update. Then we'll continue to do this. Here, click the conrod and now click the crankshaft. Can also then we can do the offset constraint between this surface to this with same value to mm. Now the icon for update all is highlighted when we click it, so that it is positioned there. Next is we want to align the piston. This is the piston number 1, number 2. Click update. Then the next piston, update. Then the other piston, update. Then what we need to do is align the piston holes with the conrod. That is, use coordinate constraint, select these holes and select these matching holes in the conrod. Update. Another one. Update. And the last one. Update. Okay, so finally we have 3 pins left to assemble in this assembly. Click here and click this. It will align, so we can set the face of the pin to the face of this piston with offset 0. Click OK. So I'll update the first pin. Right. Next, we'll do the next pin. Zooming in and offset constraint. And this to this. Click 0. OK. Update. Next, this one and this. Next, we set the offset constraint between this surface to that surface 0. Okay, update. Alright, so we have connected all the parts same as this. Basic kinematic manipulation. So this is where we can see the capabilities of assembly. That is, it can do manipulation with its kinematic. How to do that? Let's start with select tool manipulation. That is the one that we have used previously. Move, select drag along y-axis. So we need to select this axis and check this box with respect to constraints. Then select the end of the crankshaft and rotate it. So let's set it as isometric, fit all in, and zoom in. Let's click this manipulation icon, and as we want to rotate this, should be, the crankshaft should rotate. Okay, so we'll click Y, drag around y-axis. Don't forget to check this box, that is with respect to constraints. Okay, so now we hover our mouse on this crankshaft. We can click and then we can rotate, move our mouse. So as we can see, this piston is moving with regards to constraint that we have done previously through the con rod to the pin and also to the piston. So if you can see also in this animation, your assembly is correct when the center two piston is moving down while the piston at both sides are moving the other directions. I stop here. Clicking OK will leave it as it is. Next, we'll continue our document. Flash. Press tool stop manipulation on flash on the move toolbox and use manipulation tool to rotate the crankshaft. If there is clash between solid parts, the manipulation will automatically stop at the clash point. So the clash is icon is here. If we click this, it means that it will stop the manipulation when it is clash. So as we can see here, if we move it, so it's still moving in 360, so there is no clash happening to the assembly. Click OK. Next, we can change the dimension or the properties as we require. For now, right click on the piston part body properties, go to graphic and change the fill color into red, select apply and OK. Okay, so we can also change the colors of this piston. Let's see, we have piston 1, go to properties, and can change the color over here. Let's look. Okay, it is inside. This one, change here, properties. Okay, not this one. Hold on. Okay, I've double click the piston. Let's see the properties. Okay. Let's see if it is in the part body. Okay, so this colors change in part bodies. You can select any colors that we want.